what are we studying today? What is the subject?
So we're gonna see an exercise about pharmacology. So the speed with which a soluble tablet of given volume dissolves increases with the surface of the tablet. This explains why drug manufacturers sometimes have to solve extremum problems. A pharmaceutical company manufactures a solid product package in the form of a small rectangular parallelepiped with a volume of 576 mm to the power of 3. So we note y, the height, and its other dimensions are x and 2x in millimeter. If we look again at the exercise, we see that the solid product is packaged in the form of a small rectangular parallelepiped with a volume of 576 mm to the power of 3. We have the height, which is y, and then the width, which is x, and the length, which is 2x. The first question: calculate y according to x.
Well, we know that the volume of a parallelepiped is equal to the product of its length, L, height, y, and width, little l. According to the drawing, the length L is equal to 2x. The width, little l, is equal to x. And we know that the volume of the parallelepiped is 576 millimeter cubed. And so we have the height y, which is equal to 576 over 2x squared. Now we're going to answer the second question, which is calculate the total area S of x in millimeters squared of this rectangular parallelepiped as a function of x.
In order to get the total area of S of x, the parallelepipeds, we need to add all the areas of each faces of the parallelepiped. There are 3 different kinds of faces which are duplicated. Well, the first one, which is 2 times the length times the height. Then the second one, which is 2 times the length times the width. And the third one, which is 2 times the width times the height. And then we just need to replace by what we wrote before. Now we need to add the 3 faces, and we reduce them to a common denominator. And finally, the third question. So x is necessarily between 3 and 12 millimeter, and we have to study the variations of s over the interval 3-12 and deduce the value of x for which s of x is minimal.
We differentiate the function in order to get the variation of s, because we know that the variation of a function follows the sign of its derivative function.
Well, now we have s prime of x, and we know that x squared is always greater than 0, so the sign of s prime of x is the sign of 8 times x to the power of 3 minus 1728, which is equal to 2x cubed minus 12 cubed. So now we can use the formula and the help, which is a cubed minus b cubed, which is equal to a minus b times a squared plus ab plus b squared. In this case, a is equal to 2x and b is equal to 12. So we have 2x minus 12 times 2x squared plus 2x times 12 plus 12 squared. We just calculate it, and we obtain two different functions. 2x minus 12, which is equal to 0 when x is equal to 6, and 4x squared plus 24x plus 144, which is equal to 0. So this is a quadratic where a is equal to 4 and b is equal to 24 and c is equal to 144. So we can now calculate the discriminant, which is equal to minus 1728, so it is smaller than 0, which means that there are no roots. We can now draw the sign table. So first the sign table of 2x minus 12, then the sign table of 4x squared plus 24x plus 144. So then finally the sign table of s prime of x, and then the variations of s. Two is greater than 0, so there is plus to the right and minus to the left. 4 is greater than 0, so it's plus, and that gives us minus and then plus. So s decreases and then increases. We just need to calculate s of 3, which is 612, and s of 12, which is 720. And then we have our the answer to our question, which is s of 6, which is 432. So in conclusion, s of x is minimal for x is equal to 6.